Students, in our previous classes, we have learned what is a progressive wave and we have learned the basic equations of a progressive wave. Now, like our previous classes, we will draw the usual graph, that is for the progressive wave, how does the particle of the medium executes a SHM as the wave propagates through it. We will put it in the form of a graphical representation. So, like our previous classes, here also we will assume a one-dimensional progressive wave is propagating in a medium along OX in the positive direction of x-axis with O as origin. Alright. So, one of the equations that we have learned that while propagating, the displacement of the particle at position P, that means we are considering this position right now, that is y equals to, that is y means the displacement of the particle, okay, and we are considering this position, that is P position. Alright, so y equals to a sine omega dash t. Okay, this was our equation, and we have learned and we know that the time taken by the wave to reach point P, that means from here to here, that means from O to P, whatever time will be taken by the wave at a distance x. See, this is the distance x, that is the distance of OP is x. Alright. On the right hand side of O, that means this is the right hand side of O, is x by v. That means we are expressing with respect to time. Okay. So we can write the value of t here as a sine omega t minus x by v. In the previous equation we had, since y equals to a sine omega t dash, we are expressing the value of t dash in the second equation as t minus x by v. Okay. So another form of expressing this equation as a sine 2 pi n within bracket the same thing, that is t minus x by v. Okay. So we have seen this equation in our previous classes. So now we will learn the alternative forms of this progressive wave. Okay. So let us consider the angular function to be as theta. Just simply consider theta as your angular function. Okay. So how we can express the value of theta? We can write the value of theta as theta equals to omega within bracket t minus x by v. Okay. So we can put the value of theta from this equation as theta equals to omega t minus x by v. Alright. So by expressing theta in different forms, the equation of the progressive wave, that means those equation of the progressive wave we have studied, and you can consider these equations also. These equations also you can consider, and it can be expressed in few alternative forms. Okay. So the value of frequency that we can get from this equation is n equals to omega by 2 pi. We are putting small n for this frequency. Okay. So n equals to omega by 2 pi. What will be the value of time period? Time period means 1 by n. So 1 by n equals to 2 pi by omega. Okay. And the wavelength value is v by n. Okay. V means your wave velocity and n is the frequency. Okay. So the angular wave number, that is k, that we have seen in our previous classes, can be expressed by 2 pi by lambda. Okay. So now you can put the value of lambda in this equation and we can get the value of k as omega by v. Okay. This data that we have got by putting all these values. Okay. So let us write the first and alternative form of the progressive wave as the first form. Okay. I hope you have learned that how we can express the values of this frequency, time period, as well as the angular wave number k by putting the values. Okay. Okay. So now let us write the first form of the progressive wave. See. We can write the value of theta as omega t minus x by v. Previously we have learned that we can express the angular wave function theta as omega within bracket t minus x by v. So in the next step we can write it as omega t, that means just we are opening the bracket. Okay, so just multiply omega with the rest of the terms. So omega t minus x by omega x by v. Alright, so we can write in the next step as omega t minus kx, because previously we have written the value of angular wave number k as omega by v. So we are simply putting here, instead of writing omega by v, we are writing it as kx, because as k equals to omega by v we have learned previously, so we can write it as in the form kx. Okay, so this is one of the form. So let us express the other forms. Let us learn the other forms. Another form of expressing theta as omega within bracket t minus x by v within bracket we have written, and omega within, and let us put the v in the denominator. This we are just doing by mathematical way. Okay, so within bracket it will be vt minus x. Since there was no v, we are taking it as like this. So for this term we can express omega by v as 2 pi by lambda, and within bracket the same thing that was there in the previous day, we can write it from this. That means this thing will be same. Alright.